Hello everyone, this is Sam Lochterman with Datavolo, and today we're going to review building secure chatbots with Datavolo and Snowflake. So as we customize LLMs and chatbots for enterprise documents and data, many companies are realizing that proper user-specific authorization is needed to ensure the security and compliance of these new AI-powered tools. In particular, as different users have different levels of access to source documents in systems such as Google Drive and SharePoint, we really need an approach to synchronize authorization metadata as well as other forms of metadata in order to give the target platforms the right context. In this tutorial, we're going to build a secure chatbot from a set of unstructured documents using Cortex Search and using role-based access control for each user. The source data is going to be a collection of financial 10Ks and 10Qs from companies like Apple, NVIDIA, and others, and these will be available in the source systems I described. Datavolo is going to be used as the data pipeline layer. So we're going to receive, in an event-driven fashion, notifications from these source systems. We're going to process those events in order to synchronize the authorization metadata down to the Snowflake platform, and we're going to store those permissions in a mapping table. We're then going to build a secure chatbot using Streamlit that will make use of this authorization metadata as well as the chunks of these financial 10Ks that Datavolo has pushed to Snowflake to enforce at the point of access the appropriate authorization so that each user will only see the chunks that are relevant to them. All right, so a few different steps we're going to go through today. The first is modeling the authorization metadata in Snowflake tables. The second will be using Datavolo Cloud as a native app and Snowpark container service within Snowflake. We're going to build the Datavolo pipelines. We're going to build the data pipelines in Datavolo using Datavolo's UI for flow authorship. That will allow us to implement that event-driven ingest I mentioned. And finally, we're going to use Streamlit to implement this secure chatbot, which is built on top of Cortex Search and the tables that we've populated. All right. So just taking a look at the overall architecture here, you'll see that Datavolo running in SPCS will be the home of the data pipelines, both for authoring these flows as well as operating them and maintaining them. We're going to use Datavolo's ML-driven transformation processors to detect the layout of these documents, to figure out which specific annotations we need to derive, such as what is a section, what is a title, what is a table, a chart or figure, and each of those document components will be routed to different downstream parsers to make all of that data useful for consumption. We're going to, once we've prepared all the data, synchronize it to the Snowflake platform. We're then going to build these functions I talked about for Cortex Search to retrieve the right document chunks to service user queries. And we're going to do that in a context-aware fashion so that users only get the best answer for them based on the authorization they have in the source system. All right, so the first step will be completing the data model within Snowflake. So we have created a specific database to house these tables. They are right here. So we have financial reports. These are going to store all of the document chunks. We'll do the chunking and the layout detection in the data pipeline side. And then we're also going to persist all the permissions. These will be tied to individual documents. We're going to use the Snowflake user's login as their canonical identity, and we're going to map other identities associated with that user with the email address associated with their Snowflake login. So for instance, if I have an identity associated with Google as my IDP for Google Drive, or with Microsoft IDP Azure AD for SharePoint, I can map those identities to this canonical representation of the user, which we're going to use their Snowflake registered email as that source of truth. All right, so that's our overall data model, and we'll come back to this shortly. After we have defined these tables, we're then going to deploy Datavolo Cloud as a Snowflake native app. So I've actually completed all these steps behind the scenes. We have a full GitHub repo here with all of those specific steps, including setting up the key pair for authentication, using the Snowflake CLI to create a connection for our account. We have a set of provider resources, and we've synced our Datavolo Cloud Docker images to the Snowpark container registry. And then on the consumer side, we'll use those assets to create the warehouse, grant permissions that are required for these applications, and then we will have some additional scripts which complete the deployment of this service as a Snowpark native app. All right, this has been completed, as I mentioned, in the back end. So within my Datavolo IO database, our data warehouse in Snowflake, I can then identify what is the public URL for this application. So let's open a new browser window and navigate there. And it's going to ask me to authenticate with my Snowflake credentials to this ingress service, which is going to give us access to the Datavolo UI. And because we are using our Snowflake credentials here, we're going to use that as the canonical identity in these mapping tables that I mentioned. So let's sign in here. All right, so now we've signed into the Datavolo UI. All right, we have now signed into the Datavolo UI, and we're ready to implement the data pipeline. So the first thing I wanted to talk through is the Google Drive change data capture process group here. So this flow is going to capture new changes from Google Drive using their notification API. So we have a controller service which authenticates us to Google. We have a specific Google Drive folder that we're looking at, and it's going to listen for notifications associated with either content or context changes on those source files. Based on a change, we can then fetch that full file from the directory. We're going to set some metadata on the file, such as what document ID it is, the source file name, the source readers, and doing it in this format here will abstract any details as far as the underlying source system. So we can do the same sort of metadata capture for SharePoint as well, for example. All right, so at this point, we have specific documents. We don't know yet, because of API details, whether the content or the context has changed, but Datavolo can easily handle both. So as I drill into this duplicate content check, we're going to just hash data that we've seen before. If the content has changed, we won't see that hash in our lookup table. We've created this lookup table inside of Snowflake using this controller service with this SQL here. And so whenever the content has not changed, we're going to have an existing record in this file hashes table, and then we know that this is a metadata only change. And so we're going to check to see whether the metadata changed or the actual data. In the case of a metadata only change, we're not going to have to reprocess the content. And if this is a brand new file, then we will go ahead and run it through the full pipeline. All right, so we're then going to look at how we actually structure these documents and make them useful for the AI application, our secure chatbot. So as I drill into the structure PDF documents process group, we can see some of those details. So for the parse PDF processor, This is using some machine learning services that are also deployed as Snowpark containers. It's just going to talk to those services over HTTP. And what we're going to get as output, if I use our data provenance capability, we're going to get a couple of additional output from this computer vision model. We're going to get both a bounding box and a label around every specific subcomponent of this document. So I can jump into Datavolo's PDF viewer here, and if I were to scroll down to, let's say, page 21, I can see that this specific data table was labeled as such, and therefore when I parse it, we're going to want to send those tables to our table router, and then I'm also going to have things like charts and figures and other more complex information inside of this. So this is going to be useful to know what is a chart, what is a figure, what is a table, and how do I need to parse those subcomponents. All right, and then just to give you an idea of what this looks like in the back end, this output is captured in this JSON format with those labels like section or narrative text, with the bounding boxes, as well as some confidence scores returned by that computer vision model. Perfect. All right, so the next part is we're going to parse those table images using a specific ML service. Again, this table structure recognition service is also deployed within Snowpark. We gave it some GPU compute in the compute pool, so it can do this in a very performant way. Once we have that table extraction into this CSV style format, we're then going to prompt Cortex as a language model. We're going to use Llama 3.1 here. The 8 billion parameter version is fine. And we're just going to summarize what's contained in that tabular data and get some natural language back. When we do an embedding, we're going to embed that natural language. This is also going to be useful when we do retrieval. We're then going to merge all these elements together, so the chart descriptions, the tabular extraction, the descriptions of those tables, and then all that narrative text with all of the ML-derived annotations. Excellent. So then at this point in the flow, we can go back in the UI to the final steps here. We then need to chunk our documents. So for Snowflake, we're just going to do structural chunking. We're going to remove prior chunks because we might have processed this document in the past and might have used a different chunking strategy. So we'll purge any earlier chunks, and then we're going to chunk by section. So this strategy, it just uses those labels. It's going to take each section in that JSON and give us back the text associated with it. And we can tune some things like our subsection strategy, max chunk size, overlap, etc. For this use case, these values will work really well. All right, and that's what we're then going to write down to the Snowflake side. So within this last process group, we're going to do a few different things. So if we just had to reprocess the document, or if it was a new document, we would then send all of the document chunks to Snowflake using the SQL statement here. You can see we're using our Datavolo expression language, pulling in some values dynamically, but straightforward insert statement into that financial reports table. For the permissions, very similar. We're going to merge these into the financial report permissions. For every user, we're going to store their appropriate access control, whether they can read the file, and we're going to use those permissions to determine how these chunks are retrieved by Cortex Search and therefore returned to the end user. And if documents get deleted on Google Drive, then this will work excellently as well. All right, so that's really the Datavolo data pipeline logic. Let's go back to our walkthrough here. All right, so we've created our pipeline. We're then going to create the secure chatbot in Streamlit, which is also going to be available within the Snowflake platform. So let's take a look at the backing data that we use for the Streamlit secure chatbot, we're going to implement a Cortex search service to expose to the front end. And to build that service, we need to create this view. This view is going to bring in the authorized readers from those permissions that we just synchronized using the Datavolo pipeline. So we have this nice view. We're then going to build our Cortex search service. It's going to use authorized readers as an attribute. You can think of this as a facet, something we can filter on. And when we build our custom function to implement this, it's going to pass in the authenticated user context from the front end. All right, so those are our backing views. We're then going to build the Streamlit app. I just want to call out the specific Cortex search service. This is where we're going to use that service we just defined. We're going to wrap it in this definition. And so when we have a query from a user, the first thing we're going to do is use that Cortex search service to retrieve the relevant document chunks. And for the user's prompt, we're also going to, when we query the service, we're going to pass in the authorized reader from the authentication event associated with this front-end app. All right, so this looks really good. We have a little bit of a system prompt here to make sure that this chat assistant is going to do the right retrieval operation for us. And now we're ready to go to the Streamlit side. All right, so this is my Streamlit app. I'm going to turn on debug so we can see different documents and different document chunks get retrieved in the back end. And we have a few different questions we want to ask this chatbot. So we're first going to ask more of a simplistic question. What was Apple's revenue in the 2023 fiscal year? And for this scenario, the user does not have access to the 10Q documents, i.e. the quarterly financial period. The user only has access to the annual reporting period, the 10K document. So we can ask questions like this that are about the 2023 fiscal year, but what we might want to do as an analyst that we're currently constrained to do is we can't ask questions that are going to require access to the 10Q documents, the quarterly documents, to get the answer. So we can see that the chatbot is telling us it doesn't know the answer to that question. All right, so now as a user, I'm frustrated. I don't have access to this. I'm going to talk to my Google Drive admin. I'm going to submit an access request and get granted some additional access. All right, so in particular for this 10Q document, I want to give my user Joe Witt access to the quarterly data as well as a viewer. We're going to save that permission change, and then we're going to go back to our Datavolo pipeline. All right, so let's go back to our write to Snowflake. So we actually see two additional events that have just been digested. If I go to provenance, we can see that a moment ago we executed a new SQL statement. That SQL statement is going to actually push those new permission records to our table. So let's go back to our chatbot in our Streamlit app. And now we can ask that same question. The Cortex search service does require 1 minute of reindexing or reorganization after we push new data. So if we ask again, what was the revenue for that quarter ending April 23, we should get a different answer. And if we look into these debug steps, we see that we now actually have new documents returned. So we have this 10Q document returned for Q1 23, and indeed the user was now able to get a different response, a better response, since their access to Apple's financial results were broadened, and we can now answer questions about quarterly financial data as well. Okay, that's awesome. We want to just show one final thing from a Apple revenue standpoint, and we do have our Datavolo app that's running here. That's what allowed us to expose this data pipeline. All right, so we were able to show the secure chatbot providing us context-aware answers for each user. We saw Datavolo running as a native app within Snowpark. I could deploy this in my account. I now have my data pipeline running. And we saw that different users, based on their context, their permissions, are going to see different results in our chatbot app. All right, thank you very much.